Welcome to today's Read Aloud. We're going to be reading about the rock cycle today, book by Wendy Conklin. Let's take a look. Ooh, a long journey. Have you ever had the urge to change into something else? It can be hard for humans, but rocks do it all the time. Rocks? The same rocks that look like they're just sitting there doing nothing? Yes. Rocks are constantly on the move, but the movement is so slow that it's hard for us to see. But if you could keep your eyes open for a couple million years, you could watch a mountain turn into sand. These drastic changes in rocks are part of the rock cycle. A cycle is a set of repeating patterns. In the rock cycle, rocks constantly form, destruct, and recycle. There are three basic types of rock: sedimentary, metamorphic, and igneous. Over time, one type of rock can change into another. Rocks change through weathering, heat, pressure, and erosion. Rock on. Some of those words should look a little familiar to you. Get out of here, Coot. I don't want you. That's not what we're talking about. Introducing Igneous Rock. Okay, that's exciting. How exciting would it be to see a volcano blasting hot lava from its center? But did you ever wonder where this hot lava comes from and what makes it rise to the surface? And what does this have to do with the rock cycle? It's amazing to think of Earth as one gigantic rock. Earth's outer layer is known as the crust. Underneath Earth's crust lies the mantle. This is a layer of extremely hot rock. Rocks that rise from the mantle melt because of the intense heat found there. This melting rock forms magma. Some magma stays underground, but when magma pushes up to Earth's surface, a volcano erupts. Magma that reaches Earth's surface is called lava. Air causes lava to cool and harden. Finally, igneous rocks form. While it can take millions of years for other types of rocks to form, some igneous rocks can take just a few hours. But why does magma rise to Earth's surface? Let's take a look at the notes on this page before we answer that question. This is volcanic rock. It means this rock that came out of a volcano. The least dense rock on Earth is called pumice. Pumice is formed when lava cools quickly and air bubbles form. See all those little bubbles? With so much air, the rock is less dense than water, and it can float. Imagine that, a rock that can float on water. Extrusive or intrusive? There are two types of igneous rock: extrusive and intrusive. Extrusive igneous rocks are produced above ground when lava hardens after a volcanic eruption. Intrusive igneous rocks are produced when magma slowly cools underground. Pumice is used in products people use every day, such as makeup and toothpaste. Oh, who knew? Get out of here, Coot. Breaking up is hard to do. Earth's crust is broken into many large pieces called tectonic plates. Plate boundaries are where the plates meet. It's at these boundaries that many igneous rocks form. So we got all these plates moving around here. There we go. These are different land masses floating on the plates, and the plates push up against each other. And at the boundaries, you get these igneous rocks, these volcanic rocks. Some plates move apart while other plates move towards each other. This movement does not happen overnight. Instead, it takes years and years to notice this movement. When plates move apart, something has to fill the gaps. This is where magma from the mantle rises and melts. The magma forms new crust in the gaps. It cools and produces igneous rock. When the plates move toward each other, sometimes one plate sinks into the mantle, allowing the other plate to rise. The plate that sinks melts from the heat and forms new magma. The mid-Atlantic ridge is the meeting place of tectonic plates and can be seen in Iceland before it disappears again into the Atlantic Ocean. So here's a place where two plates are getting together, closer and closer and closer. When tectonic plates slide past each other, the Earth quakes. Did you know that? The earthquakes are caused by two tectonic plates grinding and sliding past each other. Ooh, Pangea. Let's talk about Pangea, yeah. Ooh, no, come back. There we go. Pangea, hundreds of thousands of years ago, all the continents were connected. Now, this is a misnomer. It's actually millions of years ago. They formed one giant supercontinent called Pangea. the tectonic plates slowly moved and drifted apart. A water body called the Tethys Sea helped split Pangaea in two. Hotspots. At times, magma finds its way to Earth's crust through hotspots. Hotspots are exactly what they sound like, areas where the temperature is extremely high under the Earth's tectonic plates. Let's talk about igneous rocks being so cool before we wrap up for today. If you were searching for igneous rocks, where would you look? Near a volcano would be a good choice. Here, the tectonic plates move toward one another. Volcanoes form at these places. When lava flows, it cools and hardens into igneous rock. If lava blasts into the sky, it may cool and harden while still in the air. When this happens, it's called a volcanic bomb. Think of it like a bottle of soda. If you shake the bottle, the gases separate from the liquid and bubbles form. When you take off the cap, it explodes. Similarly, gases in magma break apart when it erupts. Volcanic rock and ash are sent flying into the air. Over time, igneous rocks will also form the layers of the ashes. So it's kind of, you can think of a volcano exploding outward as being like the gas pressure in a soda can as you shake it up, right? There's gas forming in there, and it's getting expanding, and it's bubbling. It's saying, I want out, and eventually, if you shake the can hard enough, or if enough gas forms in the volcano, it can explode outward and release these volcanic bombs. Another good place to look for igneous rocks is underground. Some magma doesn't make its way through the crust. Instead, it cools near the crust, and rocks form under the surface. Under the ocean is where you'll find the most igneous rock. Igneous rocks can form when plates move apart. This plate movement often takes place on the ocean floor. Lava reaches the water and cools, making igneous rocks. Igneous rocks can change over time. Wind, rain, snow, and ice wear rocks down into tiny pieces. Sedimentary rocks form from this weathering. And if igneous rocks get hot and are under enough pressure, they turn into metamorphic rocks. Next time we read, we'll read about metamorphic rocks. Bye for now.